Yes guys, we are doing question number 7. Now in question number 7, what we have to do? Now we have calculated AB, whole inverse we were calculating, but AB comes out to be this value, and when I calculated the determinant of this value, it comes out to be 0. That means this is singular one, so we cannot find out AB inverse. AB inverse is not possible, or because determinant of AB is 0 or is singular. This matrix is singular, we cannot find out this. Now, if there is any mistake, let me check whether right hand side also comes out the same. Okay, so then let me check. Otherwise, okay, this kind of problem rarely occurs, but let me check. So now, B inverse and A inverse we have to find out. So what is the A and B? Let me just find out determinant of A, determinant of B. First, here A is equal to 1, 1, 2. This is 7th question. 1, 1, 2. Yeah, 1, 9, 3. Oh, sorry, it is 1, 9, 3. Not 1, 9, 2. I'm sorry. It may be because of this mistake. This is 1, 9, 3. The 7th question. I took it as 2. So that it may be a mistake. I'm sorry. So this is 3 here. It means the calculation of this AB. Let me first find out what is the right hand side. Then I'll calculate this again. Not a problem at all. Okay, not a problem. But this problem is here it is 3. Okay, and even if I take that as 2, because I have taken it as 2, then value was okay coming as that one. But let me, because I just mistaken, I took it mistakenly as 2, not 3, because that problem has come. Okay, no problem. Now let me take 1, 9, 3, and this is 1, 4, 4. And so therefore, first of all, before finding A inverse, let me find out determinant of this value. The determinant of A will be equal to 1 into this 1 into this. Let me find out the determinant. This is minor here, 9, 3, 4, 4. Right. Minus sign, this is 1 into, again this is 1 into this 1. Okay, just like cofactors we have calculated this. So for 1, this is 1, 3, 1, 4, and then plus 2 is plus 2, and this is 1, 9, 1, 4. Okay, now let me find out value of determinant. 9, 3, 9, 4 is 36. 36 minus 12. Okay, minus 1 into, let me calculate this. This is 4. 4 into 4 and minus 3. Plus 2 into 4 minus 9. Okay, so it comes out to be 36 minus 12 is 24. Minus this is 1 here, 4 minus 3 is 1, which is 1. Plus this is 4 minus 9 is minus 5. Minus 5 to 10, which is minus 10. This is minus 10 here. So 11 minus 11 and 24 minus 11. 24 minus 11 is 13. Okay, so it is 13 here. The determinant value is, let me write here, 13. Okay, so this value is coming. It means the value is not singular, because this one I took it as 2, so that AB was coming as, I will just calculate this again, no problem. Okay, let me first find out what is B inverse, A inverse. Now A inverse, for A inverse we have to find out A inverse equal to, this is adjoint of A divided by determinant of A. For that adjoint of A, we have to find out what is matrix of cofactors. No, matrix of cofactors of A. Here A. Let me take this A11, A12, A13. Okay, this is A21, A22, A23. This is A31, A3 2 is A3. Now let me calculate all these values. This is A11. A11 for A here. So this is A here. This is 1. Okay, for 1, this is 9 4 is 36. Minus 12, that means 24 positive value. A12 we just calculated, and A12 is for 1. We will calculate this. This is 4 1 is 4 minus 3, it is 1 plus negative 1. So this is negative, this is minus 1 here. Okay, so this is minus 1. Then A13 for 2. Okay, cofactor of 2 is 4 1 is 4 minus 9, this is positive value, so this is 4 minus 9, this is minus 5. These three values are set. Now A21 is odd number, so it is negative value for this one. It will be 4 1 is 4 minus 8. 4 minus 8 is minus 4 minus plus 4. Then A22 is equal to, this is positive. Okay, A22 is for 9. What is cofactor of 9? For 9, this and this, so it is 4 minus 2. It is 4 minus 2. But 4 in the 4 and 2 in the 4. It is for 2 only. So let me calculate here. It is A23. It is negative sign, minus sign. A23 here. Negative value. Okay. A23 means this one. For 3, it is 4 in the 4 minus 1. So 4 minus 1, that means it is minus 3. Alright, it is minus 3 here. Minus 3. Then A31. A31 for 1, cofactor for 1 is 3 1 is 3 minus 18. 3 minus 18. It is positive value. A31 is positive. For 3 plus 1 is positive here. A3 1. Okay, so it is positive. So value comes out to be negative. It is minus 15. Minus 18 plus 3 means minus 15. Now A32 for 4. This is A32. That is equal to how much? For 4, this and this. It is 3 1 is 3 minus 2. This is negative value. 3 minus 2 into minus 1. It is minus 1. Now A33, let me calculate here. A33 for 4. It will be 9 into 9 minus 1. It is positive value. 9 minus 1, it is equal to 8. Why 9? Because 9 into 9 minus 1. That means 8. Positive value. Therefore, this cofactors, matrix of cofactors, of A. Let me write that. This A11 is 24. It is 24 here. A12 is minus 1. A13 is minus 5. Number A21 is 4. Then A22 is 2. Then A23 is minus 3. A31 is minus 15. Then A32 is minus 1. Okay, and A33 is 8. Positive value 8. This is cofactors value. Therefore, adjoints of this is adjoint, but we have under adjoints transpose of this. Therefore, adjoint of A. So we have to transpose this. This is 24 minus 1 minus 5. It is 4 minus 3. It is minus 15 minus 1 8. This is adjoint of A. Now, adjoint of A divided by 13. This is the value of A inverse. Let me now write A inverse. Therefore, A inverse is equal to 1 upon 13. And this value, this is 24 4 minus 15 minus 1 2 and this is minus 1 here. It is minus 5 minus 3 and 8. Okay, this is A inverse. Now B inverse we have to find out. Let me find out now B inverse. Then we multiply B inverse into A inverse. Whatever value comes out, that will be equal to the left hand side. Okay, but left hand side I just calculated mistakenly. I put it 2 here. I could take 2, no problem at all. Then answer will be same. If I had taken 2 for A inverse also, only in A there was a mistake. Okay, let me, if I take it is 2, let me take it as 2. Okay, so that this is 2 here. Okay, no problem. It is not 3. Let me take it as 2. Then what happens? So AB was coming, determinant of value A was coming as 0. Okay, so what about A inverse now? Now if I find out A inverse with 2 here, let me take that. What the value of determinant of A? This is 2 here. Let me take 2. Because I have done this AB as this, so A must also be the same thing. So let me take it as 2 more. Determinant of A will be then 1 into 9 4 is 36 minus 8. Okay, then minus 1 into 4 1 is 4, 2 is 2 minus 2, then plus 2 into 4 is 4 minus 9. This value comes out to be 36 minus 8. It is 28 minus 2, or this is 2 minus 2. This is plus minus 10 here because minus 5 is minus 10. It is 28 minus 12. 28 minus 12, that means 16. Yeah, 8 minus 2 is 16. It comes out to be 16 here. No problem. So A is 16. Determinant value of A is 16. It is coming. No problem. But I have taken it as 2 because as I took here, it was 2. So that is not a problem. AB inverse we will calculate. B inverse into A inverse we have to find out now. Okay. And this AB was coming as 0. No problem. Now A inverse, again I have to calculate. For A inverse we have to find out cofactors. Matrix of cofactors. Matrix of cofactors of A. Again I calculate A11, A12, A13. This is A21, A22, A23. This is A31, A32, A33. No problem. Because I have taken it as 2, not 3. Now let me check that what the same value comes out to be or not. Okay, so A11, let me calculate here. For A11, this is 9 4 is 36 minus 4 8 is 28 again. A12, this is for 1. This is negative value minus sign cofactor of 1. Is 4 1 is 4 minus 2. It is minus 12. Then A13 for 2 we have to find out. It is 4 1 is 4 minus 9. That means minus 5. A21 for 1 we have to calculate. For 1 if I calculate, then this is 4 minus 8. It is minus 9, 4 minus 8. That means minus 4 into minus 8 is plus 4. Okay, it is plus 4 now. Then we have calculated A22. Now for A22 means for 9. Cofactor of 9 is what? This is this and this is 4 minus 2. It is 4 minus 2, that is 2 and 2. A23. Next is A22 is negative because odd number. it's negative. For 2 here we have calculated 2, this and this is 4 minus 1, that means minus 3. Then A3 1, A3 1 is for 1, it is 2 minus 80, it is positive, so it is 2 in the 2 and minus 18, it is nothing but minus 16. Alright, then A32, how do you calculate A32? A32 is 4. For 4, what is cofactor of 4? In the third row, second element, 4. Cofactor of 4 is to be calculated by leaving this and this. It is 2 minus 2, 0. It is 0 here. Negative 0 or 0 only. But 2 minus 2. Right. For 4, last is A32. Cofactor of last 4 value. This 4. Cofactor of 4 is 9 1 is 9 minus 1. It is 9 minus 1. That means 842. So therefore matrix of cofactors written that way. Matrix of cofactors. This value is equal to written that. A11 is 28. A12 is minus 2. Then minus 5. Then A21 is 4, A22 is 2, A23 is minus 3, A31 is minus 16, then A32 is 0, A33 is 8. This is cofactors matrix. Transpose of this, therefore adjoint of A is transpose of this. That is 28 minus 2 minus 5, it is 4, 2 and minus 3, it is minus 16, 0 and 8. This is adjoint of A. Therefore, and 16 is value of determinant. Therefore, A inverse is equal to how much? Let me now write A inverse. Therefore, A inverse is equal to adjoint of this is 1.16. In bracket it is 28, 4, it is minus 16, okay, it is minus 2, 2 and 0, it is minus 5, minus 3 and 8. Okay, this is the A inverse. Now B inverse, let me calculate. What is the B inverse now? For B inverse, let me take the B matrix. Matrix B is this. First, let me calculate what is determinant value of B. This is 1 into 3, 3 and 9 plus 1. And minus sign minus 2 into this cofactor of 2. Okay, of 2 is 3 to the 6 minus 1. This is 6 minus 1. 3 to the 6 minus 1. Okay. Then plus. Okay, 0 is plus 0 into something 0. It is 0. Third element is 0. Okay, 0 comes out. This is 9 plus 1 is 10. Minus 6. Okay, it is 10 here. 0. Determinant value B comes out to be 0. Alright. Now we cannot calculate B inverse. B inverse is not possible. Therefore, B inverse is 1.0 means, and if I multiply this A inverse into B inverse, when determinant value B is 0, 9 plus 1 is 10, and this is 6 minus 1 is 5 minus 5 into 2 is minus 10, 10 minus 10 is 0. The determinant value is singular. Now it is okay. Therefore, B inverse does not exist in this case. If it exists, if inverse exists and it is unique, but in this case it doesn't exist because B inverse is adjoint of B upon determinant of B. Determinant of B is coming 0. Something upon 1 upon is 0. Something upon 0 is infinity, not defined. Therefore, if I multiply this infinity value to any number, that becomes infinity. Therefore, B inverse into A inverse. Just one value. By mistake, I took it as in place of 3, I have taken here 2. Only because of this 2 value, the value doesn't exist. Both are coming same. Therefore, B inverse A inverse equal to is does not exist. B inverse A inverse does not exist. Okay, because we cannot calculate. Therefore, left hand side equal to right hand side. That was also not existing. Determinant of AB is 0. AB inverse was also not possible. This is also not existing. This is right hand side is also not existing now. So B inverse will come out to be non-existing. Alright, this is B inverse into A inverse is also not existing. Therefore, left hand side is equal to left hand side is equal to right hand side. Simple. Otherwise, if I had to change it to 3, then there will some value will be lying. Okay, then in both the cases, whatever the values are there, left hand side must be equal to right hand side in this case. And we have proved this. This is what that both sides are not existing. Inverse of left hand side and right hand side are not exist. That is exist. Okay, so that is the question number 7 here. We have taken the change the value of it, and because of that the problem has occurred. Okay, that is the inverses are not existing. That is the point here. Now let me take question number 8. Okay, now question number 8 we put that back. Okay, now question number 8 is of what kind? Let me check. Okay, now question number 8. Let me check it. Okay, now question number 8 says if A is equal to this, then find A inverse. Okay, and show that A cube is equal to A inverse. Alright, this is also here, so no problem at all. Let me take it is question number 8. It says if A is equal to the determinant here 3 minus 3 4. Let me check it. 2 minus 3 it is 4. Okay, different value. It is 3 minus 3 4. 2 minus 3 4. Okay, it is 0 minus 1 1. Alright, this is A here. If A is equal to 3 minus 3 4, 2 minus 3 4, 0 minus 1 and 1. Okay, then to find A cube, A inverse also we have to calculate. Find first part is find first part A inverse. Second part to show that second part is show that A cube is equal to A inverse. Okay, this is a different kind of question or problem. Now let me first A inverse let me calculate, then A cube we will calculate, no problem. First is A inverse solution here for A inverse. Here A inverse we know is equal to adjoint of A divided by determinant of A. This is the definition of inverse of any matrix. Now what is determinant A? Let me calculate. Determinant A will be 3 into, let me take 3. This is minus 3 into 1 is minus 3. Minus sign in but it will be plus because 4 into minus 1 is minus 4. Minus sign in between we is 4 here. Okay, then minus minus plus because in between you put minus sign but it is minus 3 already, which is equal to 3. Okay, then cofactor of minus 3 will be this, and this left out is 2 minus 0. 2 minus 0 because 4 into 0 is 0. Then it is 4 into 2 into minus 1 is minus 2 and then 0. Okay, this value comes out to be minus 3 plus 4 is 1. 1 into 3 is 3. This is 3 to the 6. And it is minus 8 here. 4 to the 8. Negative 8. It is 9 minus 8. 9 minus 8 is 1. Determinant value of A is 1 only. Let me write here. It is 1 here. No problem. Now for A inverse, adjoint of A, for adjoint of A, the matrix of cofactors, let me first find out. Matrix of cofactors of A, let me take this is A11, A12, A13, A21, A22, A23, A31, A32, A33. This is matrix of cofactors. But all these values we have to find out cofactors of every element. What is cofactor of 3 here? A11. So let me find out A11. That is cofactor of 3, first element. What is cofactor of 3 of first element? It is minus 3. Minus 3 into 1 is minus 3 and plus 4. It is only 1. And A12 is for minus 3. What is cofactor of minus 3? It is 2 only. So it is 2, it is minus sign here as well. That is negative value. The negative value of minus 3. So it will be 2 minus 0. That is minus 2. Then A13 it is positive. A13 means for 4. Cofactor of 4 is minus 2 and minus 0. That means only minus 2. This is also minus 2. Okay, for 4, okay, minus 2. No doubt. And for 3 it was okay, 2, the plus negative 2. But it will be the minus sign. When negative it is positive value, it is minus 2 even, then it is now A21 of 2. What is cofactor of 2 here? This is minus 3 into 1 is minus 3, it is negative sign. Minus 3 minus 1 plus 4. It is difference is 1 in bracket positive 1, but it is minus 1. Then A2. A22 means of minus 3. What is cofactor of minus 3? This is minus 3 here. It is 3 only. Because it is 3 minus. This is 3 minus 0. It is only 3. Okay. So this A22 of minus 3. That is 3 and 4. So 4 into 0 is 0. Okay, so it is 3 only. Then A23. What is A23 of this 4? Which is 3 minus sign, it is minus 3 in bracket, 3 into minus is minus 3 and minus 0. No problem. Then 1 plus 3. Then A31. A31 means for 0. Cofactor of 0 will be minus 4 3 or 12. It is positive value, but minus 12 and minus plus. It is 0 here. A31 is 0. Then A32. A32 means of minus 1. It was for 0, A31. But now it is for minus 1. Minus 1 is this and that drops. 4 3 12 minus 8. So it is negative 12 minus 8. That will be minus 4. 12 minus 8 is 4, but minus sign is outside in the bracket. Then minus 4 here. Then A33. That is cofactor of 1, the last element. A33 cofactor of this 1 here. That will be, it is positive, but this row and this column left out. The minus 3 and 9, minus 9, minus sign plus 6. Why? Because minus 3 to the 6 is minus 6. But minus sign in between we keep, so it is minus plus. It is minus 3 here. Therefore, this cofactors, matrix of cofactors, A11 is 1 here, A12 is minus 2, A13 is minus 2 again, A21 is minus 1, A22 is 3 here, A23 is 3 here again, A23 is 3, A31 is 0, A32 is minus 4, A33 is minus 3. Okay, so this is matrix of cofactors of A. Therefore, adjoint of A is equal to, let me transpose this. Transposing this, is 1 minus 2 minus 2, it is minus 1, 3 and 3, 0, minus 4. What we do, we transform rows into columns, or interchange the rows into columns. This row has become first column, second row becomes second column, third row has become third column. In this way, we interchange the rows into columns. That is the adjoint of. Now transposing this, we have got the adjoint of A. This is adjoint of A, but adjoint of A upon determinant value A, which is 1, the same value is there. Adjoint of A, let me take an inverse therefore. Therefore, A inverse is equal to A inverse is equal to adjoint of A. This is this value. Same value is there because determinant value is 1. That will not change the value of this matrix. This is minus 2, 3, minus 4. It is minus 2, 3, and minus 3. Minus 3, minus 4. Yeah. Okay, so this is your A inverse value. Now let us find out what is A cube. For that, A square first find out A into A. That means A square here. Now, second part. This is second. This is the first we have calculated. This is the answer. A inverse is this value. Let us find out what is A cube. Now P says, it says that A cube is equal to A inverse. Let's check. So now first find out A square. A square is A into A. That means this value is 3 minus 3, 4. It is 2 minus 3, 4.